So we'll see here b dot b derives 0. For this the action is b dot value is 1. b derives 1, the action is b dot value equal to 0. Then L derives b, L dot value equal to b dot value, L derives LB, L dot value equal to this value plus this value. Okay, we do one example. So start with L, I'll take L derives LB and take one more L time LB, and suppose take one more time LB, and finally L will be B. Okay, this is for recursion. So to generate LB, 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 and this is once you substitute B, you don't get any other B. So B value you can place either 0 or 1. B value you place either 0 or 1. Example 0, 1, 0, 0. I am taking like this 0, 1, 0. Okay, now look at this. Here B dot value, B dot value, B dot value, B dot value, L dot value, L dot value, L dot value, L dot value. Okay. Now go for evaluating this one. So all these are at the rightmost end. Okay. And all are, one more thing, all are, even though rightmost end, sometimes they may give you here b dot value equal to L1 dot value plus L dot value, or L1 dot. So you just don't think that every time if it is the rightmost end, it is given always synthesizer attribute. So even though rightmost end, I told you now, it can be placed anywhere. So you have to look at this one. So this is parent, that is important, whether you are finding parent or child. So anyway, all these are parent values. Now go for this one. B derives 0, B derives 0, B dot value equal to 1. L derives B, so B is reduced to L. So this one, L derives B, L dot value equal to B dot value. What is B dot value? 1. Are you following? B is reduced to L. So what is the partition? LB, L derives B, L dot value equal to B dot value. Next. B derives 1, this one, B derives 1, B dot value equal to 0. Next, L dot value, L derives LB, L derives LB, L dot value equal to L1 dot value. What is L1 dot value? 1, L1 dot value plus B dot value, 1 plus 0 is 1. Are you following? LB is reduced into L, this one, L derives LB, L dot value, this value equal to L1 dot value, 1 plus B dot value 0, 1 plus 0 is 1. Next, B dot value, B derives 0, B derives 0, B dot value equal to 1. Now come to here, LB is reduced to L, LB is reduced to L. So this is L1, this is B. So L dot value equal to L1 dot, L1 dot is what? 1 plus 1, 2. Next, B derives 0, it is 1. Then L derives LB, LB is reduced to L, L derives LB, L1 dot value 2 plus 1, 3. So final output is 3. So what is the input here? 0, 1, 0. If this is the input, we got the output as 3. So which one is equal to 3? So what you can compare, how you can compare? So here number of zeros. So this is the SDT which counts the number of zeros. This is the SDT for counting the number of zeros. Counts number of zeros. Okay, counts number of zeros. Okay, now I do a small change. Suppose this is 0 and this is 1. Suppose this is 0 and this is 1. Then this will be counting ones. B dot is 0, B dot value equal to 0. B is 1, B dot value equal to 1. Counts number of ones. Okay. Next. Do you understand? Copied this one. Okay. Copied. Next, suppose I do this one. B dot value equal to 1, B dot value equal to 1 in both cases. I am taking B dot value equal to 1. Then what does it mean? It counts the total number of bits. Suppose this is the input, it will give the output as 4. For this, it counts number of bits, number of inputs, bits in the input string. Okay. Hey, Preeto Shaha. When it is derives 1, when it is derives 0, what kind of question is this? Suppose I want to count the number of zeros in the input string. That is my requirement. Whatever the input string you give, a binary input string, in that I want to count the number of zeros. Then I will design like this. If I want to count the number of ones, then I will design like this. If I want to count the number of bits, then I will design like this. It doesn't mean that when you want to take 1, when you want to take 0, it is not in my hands or not in your hands. It depends on the requirement completely. If you want to find the number of bits, count the number of bits, these are the semantic actions. Okay, everything depends on, see, whether you count number of bits or number of zeros or number of ones, for all those the grammar is same. For all those grammar is same. Exam or one more thing. Which one? Yeah, this one. Look at this one. E derives E plus T, E derives T. T derives T star F, T derives F, F derives ID. Just remember these productions. What is the input string? 2 plus 3 star 4. What is the output? 2, 3, 4 star plus. Okay, na? Okay, input string is 2 plus 3 star 4. Output is 2, 3, 4 star plus. And remember this grammar. E derives E plus T or T derives T star F or F derives ID. Now, what is the grammar here? Here also same grammar, na? This grammar, whatever just now I told you, whatever just now I showed you, so both grammars are same. Do you understand? This grammar, whatever I've shown just before, and that grammar, this grammar, both are same. As it is, no difference. But here, same input, 2 plus 3 star 4. Here 2 plus 3 star 4. There also 2 plus 3 star 4. But here the output is 14. There the output is 2, 3, 4 star plus. Everything is same. Grammar is same. Input is same. Even though we are getting the different outputs because the semantic actions. So I told you this grammar is used for only constructing the parse tree. That's it. According to the input string, the parse tree will be constructed. After that, the evaluation of the tree will be depends on completely semantic actions. So this is the grammar, and if this is the input, this is the output. And here also same input, same grammar and same input, but the output is different. So like that, mister, okay? If I change both as ones, then it counts the number of ones, number of bits, okay? Now, we'll go for different one. Next one. Don't copy, just listen. Don't copy, just listen. Do you remember how to convert the binary number into decimal? Example, a binary value of 0 or a 0 in binary representation, the value of 0 in binary representation is equal to what value of decimal? In decimal also, the binary 0 is equal to 0 in decimal. Similarly, binary value of 1 in decimal will be the same. So binary value of 0 is 0, binary value of 1 is 1 in decimal representation. Okay. Now I want to convert the binary number into decimal representation. What we do? This is 1 into 2 power 1 plus, yes or no, 0 into 2 power 2 plus 1 into 2 square. This is 2 power 1 second. This is 2 power 0, this is 2 power 1, this is 2 power 2. Yes or no? Yes or no? Conversion. So how will you convert this one? Okay, 1 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0. So 1 into 2 square is 4 plus 0. 1 into 2 power 0, 1. This is 5. This is the conversion. Yes or no? So whatever the conversion you know. So suppose 111. Okay, what will be the answer here? This is 2 square, this is 2 power 1, this is 2 power 0. This is 4 plus 2 plus 1. This is 7. Okay. Now I will tell you a different method, different approach. Converting a binary number into a decimal number. For that, what is the grammar? So for the grammar, if you give the input in the binary representation, the final output must be in an equivalent decimal representation. Okay. Now look at this. Suppose 10 10 you know 2 na. So what is the this is in binary. What is the binary value of 1 in decimal representation? 1 only na. Okay, binary value of 1 in decimal is 1. Now 1 into 2, just bring this one here, bring this here. 1 into 2 is 2, 2 plus 0 is 2. So 1 0 in binary representation is equal to 2 in decimal representation. Yes or no? Now suppose 101, you know that 101 just now we have done 5 na. So here till 10 what is the value? It is 2. It is 2. So this 2 will be multiplied with 2. So whenever we are going for the next bit, so the previous decimal value 10 in decimal representation 2 into 2 plus 1. What is the value? 2 into 2 4, 4 plus 1 is 5. Suppose 1011. So 10 when value is 5 into 2 plus 1. So this is 11. So like this procedure I will use to convert a binary number into decimal number. Okay. So same, this is the same, and whatever I have done, I wrote the grammar here for counting the zeros, counting the ones, counting the bits. Here also I do the same, this one. Okay. Now, but I change the actions. I'll change the actions. So, what is the binary value of 1 in decimal repetition? B dot value equal to 1. And what is the binary value of 0 in decimal repetition? Also 0. And L derives B, L dot value equal to B dot value. L derives B, L dot value equal to B dot value. Now the matter comes. L derives LB. So here, until here we have the decimal repetition. So for this decimal repetition, we will multiply 2. So this L dot value equal to L1 dot value. This is L1. L1 dot value into L1 dot value multiplied by 2 plus B dot value, this value. So every time this value into 2 plus 1 and this value into 2 plus 1, like that. Okay. This one. This is the SDT. See, everything is same. Here also L derives LB or B, B derives 0 or 1. Here also L derives LB or B. No sir, you wrote L1. Babu, don't say like that. L1 means I am differentiating between this cell and this cell. It doesn't mean that L1 is a new non-terminal. Yesterday I told you in the starting class, E derives E1 plus E2. Don't think that E1 and E2 are the two different non-terminals. They are the same as E. Okay? The same here also. And if you think that, I will also here make it as L1. Of course, here also I wrote L1. Na? Okay? So same grammar, but it gives different output because the actions are different. Let me check. I will check 1011. So first of all, you consider the parse tree. Consider the parse tree. L derives LB. L derives how many bits we have? 4 bits. So I want 4 bits. L derives LB. L derives LB. L derives B. So we have 4 bits. 1, 2, 3, 4. Now what is the string here? 1, 0. This is 1. This is 0. This is 1. This is 1. 1, 0, 1, 1. Okay. Now B dot value. 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 So here L dot value. L dot value. L dot value. L dot value. Now we'll go for evaluating this one. So you know that we are finding the every time parent L, parent B, and moreover B derives 0, B dot value is 0, B derives 1, B dot value is 1. You know that here B dot value is 1 and here B dot value is 0, here B dot value is 1, here B dot value is 1. Okay, I am going for evaluating. So go for this one. B derives 1, already B dot value equal to 1. Next, look at this one. B is reducing to L. B is reduced to L. What is the action? What is the production? L derives B. L derives B. So B is reduced to L. What is the action? L dot value equal to B dot value. What is the L dot value? Here, what is the B dot value? 1. L dot value equal to B dot value. That is 1. Now, B derives 0. B dot value is 0. Already I wrote. Now, look at this one. Hello guys, look at this one. Here, LB is reduced to L. LB is reduced to L. LB is reducing to L. So this is the production. L dot value, the parent value equal to L1 dot value into 2. L1 dot value into 2 plus B dot value. Okay. Are you following? LB is reduced to L. L1 dot value. This is L1. L1 dot value into 1. That is 1 into 2 plus B dot value. 1 into 2 plus 0. That is 2. Now B derives 1. Already it is 1. Now LB is reduced to L. LB is reduced to L. Then L dot value equal to L1. This is L1. Now this is the parent. This is the child. This is the child. L derives LB. L dot value. This L dot value equal to L1 dot value. What is L1 dot value? 2 into 2. 2 into 2. 4. 4 plus 1. 5. Next B dot value 1. Now finally here see L there is LB. LB is reduced to L. So protection L there is LB. L dot value equal to L1 dot value into 2. 5 into 2. L1 dot value is 5. 5 into 2. L1 dot value is 5. 5 into 2. 5 into 2 plus B dot value. Here B dot value is what? 1. 5 into 2 plus 1. 10 plus 1. 11. So what is the answer here? 11. Okay. So everything is depends on the semantic axis, not on grammar. Okay. Grammar for generating the required for the string, we generate the required parse tree. So based on the parse tree, we will evaluate the value depends on the semantic actions. So copy this. Oh shit. Okay. Copied. Next, we'll go to a different. Tomorrow I'll see. Tomorrow I'll take from 6 to 8:30. Only one session. One session I'll take 6 to 8:30. Because every one of you are requesting, so I must listen. I must give you respect. So 6 to 8:30 tomorrow. Okay. Suppose we have a decimal representation 101 or let it be 11.01. How we do in general conversion? This is 2 power 1, this is 2 power 2, this is 2 power again. This is 2 power 0, this is 2 power minus 1. Suppose one more this kya hua? Suppose this is 111.01. So how we do 2 power 0, 2 power 1, 2 power 2, and here this is 2 power minus 1, 2 power minus 2. Yes or no? Like this we will do. So 111, it is 7 na? So 1 into 2 square plus 1 into 2, 7. 4 plus 2 plus 1, yes 7. 7 plus 0 into 1 by 2 square, that is 1 by 4. 1 by 4 is what? 0.25 na? 4 2s are 8, yes, 7.25. This is the method generally you will do. So here, what is the other method I'll say, as in this previous method. So we take 1 into 2 plus 1 into 2, like that we will find. That means, see, this value is 1, okay, 1 into 2 plus this 1, 1 into 2 plus 1, 3 na, then into 2 plus this one, that is 7, 3 into 2 plus 1, 7, okay. Now in between point is there, so what I do here, plus this is also same, and means this is one more. I'll evaluate this separately and this separately, but I means a triple one I will convert into decimal, and 0 1 also I will convert into decimal. Separately I will convert into decimal. Example, 0 value in decimal is 0 into 2, then plus 1, okay. What is this 0 into 2 plus 1? So that is 1, okay. So this 0 1 in binary is equal to 1 in decimal. Now what is the formula now I use? So this I will take as L1, this part, point L2. So final value, how I will evaluate L1 dot value. What is L1 dot value? This is 7, okay na? This is L1 dot value 7 plus L2 dot value. What is L2 dot value? 1 by 2 to the power of L2 dot count. Are you following? This I will convert into decimal, 7. This also I will convert into decimal, 1. So what is the final result of this 111.01? The final value, this n dot, suppose number, this is the total number, n equal to, this is the total number. The n value equal to this value plus this value by 2 to the power of L2 dot count. L2 dot count nothing but we count the number of bits. In the string. I told you now how to count the number of bits. Then L2 dot value. What is the L2 dot value? 1. And how many bits are there? 2. 1 by 2 square. What is the L1 dot value? 7. 7 plus this 1 by 4. That is 7.25. This method I will explain. Means this method I will means here I will use. Okay, I implement this method. Do you understand? Now, what is this method I am not using. I am using this method. So what is the corresponding? Okay. What is the corresponding grammar? So grammar I will consider first. So I will take n derives L1 dot L2. One is L1 dot after L2. Okay. It is nothing but actually, hello guys, this is L1, L dot L only. This is L dot L. Okay. Next L derives LB. Or B derives 0 or 1. Are you following? Now converting binary into decimal, this is the only formula. L dot value equal to L1 dot value into 2 plus B dot value. The same here also I do. But we need the count the number of bits. So for that reason, every time count means you have to count the number of bits, either 0 or 1. So for that reason, look at this. Here B dot value. See, B derives 1. What is the binary value of 1? In decimal, 1 only. Okay. Now we want the count. So whenever it is 0 or 1, we count the bit. Okay. So that's the reason I wrote B dot count equal to 1. B dot count. Now B derives 0. What is that decimal value of this binary? It is 0. Here it is 0. But whenever it 0 comes or 1 comes, you have to count the number of bits na. So for this reason B dot count equal to 1. So either 0 comes or 1 comes, you have to count the bits to note the number of bits. And L derives B. L dot count, L dot value equal to B dot value, L dot value equal to B dot value, and similarly L dot count equal to B dot count, L dot count equal to B dot count. Okay, so same L value, L there is B, L there is B, suppose L there is B, suppose B is 0, then what? B there is 0, B dot value, here B dot value will be 0, and B dot count, here B dot count is 1. Now come to this one, my L dot value equal to B, L there is B na, this one L dot value equal to B dot value, which is 0, and L dot count, which is B dot count, 1, like that. Okay, you mean I mean this one. Now here this is the main one, next part is main. Now here L dot value, this value equal to, you know that L1 dot value, see, I am not doing anything, the same grammar I am writing here, the same grammar and the same actions I am writing, only the thing is I am adding the counting, you know already, counting the number of bits. This is the counting the number of bits, whether 0 comes or 1 comes. Here I, instead of value, better I write the count, then you don't get any doubt. Okay, I have kept the as it is. Okay, this is count, B dot count, L dot count equal to B dot count, L dot count equal to count, plus this is count, like that. Okay, now look at this. So here L there is LB, L dot value equal to L1 dot value into 2 to converting the binary number into decimal number. L dot value equal to L1 dot value, this value into 2 plus B dot value, comma, I want the count of this one. How do you get the count of this one? This count plus this count, that's it. L dot count equal to L1 dot count plus B dot count, that's it. L1 dot count plus B dot count, simple. Now here final n value, this n, the number value equal to, this is I am taking as 1 and this is I am taking as 2. L1 dot value plus, actually we count the L1 count also, but L1 count we don't require. Okay, L1 dot value plus L2 dot value by 2 to the power of L2 dot count, that's it. This is the final. So you just copy, I will give you example, I will explain and I'll give the proof for this. Copy this one. दिस इज़ द प्रॉब्लम सर, आज जल्दी छोड़ सकते हो, आप जल्दी छोड़ना, कल छुट्टी देना, परसों जल्दी छोड़ना, ऐसे करने से कब सिलेबस कंप्लीट करूं मैं? Babu, Aditi, Govindu, you need not to derive anything. So SDT will be given. That means a grammar with semantic action will be given. So input will be given. According to the input and to the given semantic actions, you have to find the output. Okay, your exam is not descriptive. It is objective, not conventional. Questions आ सकता है like this means, so I wrote every semantic action. What I do, I will leave one of the semantic action. I give the input, I give the output. If this is the input and this will be the output, then what is the semantic action? So they can ask you like this. They will leave this. They don't give this one. Example. The remaining rest they will give. Everything they will give. And input they will give. And output they will give. So they can ask you, what is here? They will give you some, okay, 1. Let it be 1. What is the value? What is the semantic action 1? Options will be there, na? A, B, C, D. You substitute the options. Verify, elimination process. So GATE examination, you are very easy, okay, because at our time it is descriptive, I think, descriptive or objective, I forgot. Okay, so anyway, it is objective, so no need to worry. Do you understand? Options will be given. To take the A option, substitute it. If input and output are matching, then go for option A. Not, then go for B. Not, then go for C. Not, then no need to check, go for D option. So elimination process, it's easy. Okay? That's all. Okay? If anybody want me to check, I will check. Otherwise, I'll go for the remaining rest of the examples. If anybody want me to check, example N, L dot L, L derives B, L derives B, L derives B, B L derives LB, B derives. Now this value is 1, this value is 1, this value is 0, this value is 1. What is the here? 11.01. 11.01. So this is 5 na? Sorry, 3 na? And this is 0, 1 value. What? 1 only na? By 2 square. So 0.25. So 3.25 should come. 3.25 should come. Okay. B dot value is 1, and B dot count. I will find the B dot value as well as B dot count, because everywhere it is there. So here B dot value equal to 1 and B dot count equal to 1. L derives LB. Sorry, L derives B. So B is reduced to L, na? B is reduced to L. L derives B. This one L derives B. L dot value equal to B dot value and L dot count equal to B dot count. So L dot value equal to B dot value, which is 1, and L dot count equal to B dot count. What is the B dot count? 1. Okay. Now here B dot value equal to 1, and what is the B dot count? Equal to 1. So every time, whether it is 0 or 1, always B dot count is 1. And L derives B, L dot value equal to B dot value, L dot count equal to B dot count. And L derives LB, L dot value equal to L1 dot value into 2 plus B dot value, and L dot count equal to L1 dot count plus B dot count. Okay. I think have you copied? Have you copied this one? Now, so like that, here L dot value equal to L1 dot value, this one, L there is LB, L dot equal L1 dot value into L1 dot value into 2 plus B dot value, L1 dot value 1 into 2, that is 2, 1 into 2, 2 plus 1, 3. Are you following? L1 dot value into 2, 1 into 2, 2 plus 1, 3. And L dot count equal to L1 dot count, this one, L1 dot count plus B dot count, L1 dot count is what? 1 plus B dot count, 1, 1 plus 1, 2. Okay, now this is done. So we will where? So we came like this. We came until here. Now this one again this one, B dot value equal to 0 because B there is 0. B there is 0, B dot value is 0. But B dot count is 1. B dot count is 1. Here also I write B dot value equal to 1 because B there is 1 and B dot count equal to also 1. Now here L dot value. What is L dot value? L dot value is B dot value. L dot value equal to L there is B dot value, that is 0. And what is L dot count? What is L dot count equal to B dot count? What is the B dot count? Here 1. Okay, next. Here, this is done. L there is LB. L there is LB. L dot value equal to L dot value equal to L dot value equal to sorry guys. L dot value equal to L1 dot value. What is L1 dot value? 0. 0 into 2 is 0 plus B dot value. 0 plus 1 is 1. Okay. L1 dot 0 into 2, 0 plus B dot value. Next L dot count equal to L1 dot count, which is 1 plus B dot count, 1 plus 1, 2. Okay. Now come to this one, N dot value. Here N dot value is, what is the rule? L1 here, N dot value equal to L1 dot value. What is L1 dot? This is L1 na? L1 dot value. What is L1 dot value here? 3 plus L2 dot value. What is L2 dot value? 1 by 2 to the power of L2 dot count. 2 to the power of L2 dot count. What is L2? This is L1. This is L2. What is L2 dot count? 2. So 2 square. So that is 3 plus 1 by 4. 3 plus 1 by 4. 3 plus 0.25. That is 3.25. Okay. Copy this, guys. Make it fast. Okay. We'll go to next. Done? Copied? I'll give you one question, you just try. So copy this one and do it fast, 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 fast. I want immediate answer. Yes, good, good. Rajnish, Neha Kumari, Rajnish Maurya. Okay. Praveen Kumar, good. Siddharth, Devang, Ansh Agarwal. Fast. Very slow. अंकित ज़्यादा टाइम लिया था आप. अंकित गौल, वैभव, मनीष. मनीष, आंसर रॉन्ग. Rahul, okay. What about other Rahul? Bilaspur, Rahul, where is your answer? Kurlan Kaur. Oh, good. Kurlin Kaur. Yogi, okay. Nirbhai Jain, wrong. Okay, Rahul. And one person is there from Bangalore. Yesterday he tested me. He told me that it was raining. Who is that guy? Pallavi Pandey, Yogendra, Ankita Das, good. Arkadi Datta. Wrong answer. Ayush Maheshwari, okay. Varun Gupta, okay. Ayush Madhur, okay. Kundan Kumar, okay. And Ashish Prasad Diondi, wrong answer. Rigiti Paul, yes, correct. Aditi Govindu, wrong answer. Ashish Prasad, wrong answer. Okay? You are taking too much of time. Too much of time you are taking. Simple, boss. I'll tell you. First of all, here we will change the operators first. Input equal to. What is the meaning of hash here? What is the meaning of hash here? Here hash. Hash is nothing but multiplication. Okay? So wherever hash is there, we will replace with multiplication. Wherever hash is there, we will replace with multiplication. Okay? Now, what is the meaning of ampersand? The meaning of ampersand is plus. Do you understand? Hash comes, you just multiply. Ampersand comes, you just add. Okay? Now, ampersand. Wherever ampersand. In as place, I have replaced with a star, multiplication. In ampersand place, I must replace with plus. Now, it will become easy. It will be easy. Okay? Now, and moreover, what is the priority here? What is the priority? What is the priority? Here, the operator which is defined at the lower level, here starting of the production, this is the lower level. So, when from bottom to top, while going to bottom to top, which operator you are getting first, or whatever the operator defined at the lower level. I need not to say this much of explanation. Okay, so you know that this is the first operator and this is the second level. So this is the least level. So this is the highest priority. This is the highest priority. What is this one? Plus. The meaning of this one is plus. So plus is more priority. Plus is more priority than multiplication. So wherever addition, you do it first. So what is the 2 into 3 plus 5, 8, 6 plus 4, 10, and multiplication is no problem. If you follow left associative or right associative, you will get the same answer. Only the problem with the subtraction and modulus and what is the division. So these are the problem. You don't have any problem with the multiplication and addition. So 2 into 8, even though if you want to go for, this is a left recursive, so left associative. So 2 into 8, 16 into 10, 160. So this you must give the answer within seconds, maximum of minute. Okay, but you are taking too much of time. 160 is the answer. 160. This is the previous question for 2 marks. You can check the previous question bank, gate question. Simple, na? And the same question also present in the workbook. I think this is the one workbook question I have done after so much of time. Earlier I think I have not done any question. Okay? And I hope you are able to do the syntax analysis question, most of the questions. I hope most of the questions you are able to solve. Anyway, tomorrow I will upload that workbook solutions. Okay? 160 is the answer. Ayush Pandar, what is this 4I3D3? Pratiksha Tyagi, Y300. Ayush Pandar, what is this 4I3D3? Kya hua? Are you using compiler language? So you converted the output into machine code or what? Huh? Next. Yeah, that's it. We'll go for a different one. Shall I give you one more? Anyway, it takes time to explain. So, in place of 3, I have written 2. That's why my answer got incorrect. Okay. Let's do one more question like this. Let's do. Okay, mister. Enjoy this question. Okay? Tell me the perfect answer. Don't give me the wrong answers. You just enjoy. So look at this carefully. Observe the semantic actions and take the priorities. Take the priorities first. Okay? Then take the values perfectly. Okay? It's you, even though you go for shortcut method, it won't come that much easily. You must be very careful. Actually, this is the question recently I designed. Okay, you don't find this question anywhere else. The priority. Yes, Priyatosh Saha. Your answer is right. All other are wrong. Whoever sent till now, all of your wrong answers. Priyatosh Saha, you are right. Ankit Gwal, wrong answer. Madhav Mishra, wrong answer. Devang, wrong. Ayush, wrong. Yogendra, wrong. Akanksha, wrong. Yogita Chand, wrong. Shalini Kumar, wrong. Amarnath, wrong. Rajneesh, wrong. Mansi Agarwal, wrong. See, I told you now. So you feel that it is simple question. But actually even I feel that it's good, but looks easy, but when you do it, you face the problem. So even in recently I have given this question in the offline batch. So this is the second batch I am giving you. So this question, and offline batch also no one has done this question except one person or two person, but they have taken so much of time. Yes, Abir Karmakar, right answer. Good. Abir, right. I am getting so much in so many different answers. 73, 135, 57, 130, 186, 73, 57, 52, 100, 135, 18, 57, again 35, 135, 24, 48, 63, 73, 23. What are these values, boss? Your weights are what? All these are wrong answers. थ्री स्टी रॉन्ग, 23 रॉन्ग, 185 रॉन्ग, 135 रॉन्ग. बाबा एक इनपुट को इतना सारा आंसर्स आते हैं क्या किसी इनपुट को, एक ही इनपुट को? 57 ये वो भी रॉन्ग है. 135 wrong, 37 wrong. You are too great here. From 1 to 200 you are giving all the numbers. All of you so much of great. So much. Great. 37. Aha. 175. Give all the numbers between 1 to 100. "24 is also wrong. 28 is wrong. Nisha Kumawat, wrong. 210. Your answer is highest answer, I think, till now. Wrong. 47, 23, 300 cross, wrong. Triple century. 29, 30 is wrong. 135 is wrong. Ali, you are correct. Rekati Paul, very good. You are correct. Rekati Paul, you are correct. Manish, you are wrong. Priyankan Kumar, wrong. I don't understand why you are taking this much of time, and why are you... Okay, you take the time, but you should not give the wrong answer, na? You are giving the wrong answer. That is not correct. 110 wrong, 210 wrong. 17 also wrong. 21 is wrong. 73 wrong. Okay? So you do this as a homework. Tomorrow we'll meet. Tomorrow is the end of the class. Means this chapter. Tomorrow I'll complete. Only 2 or 3 more questions are there. But to discuss it will take time. So that's the reason I cannot continue. Okay? So tomorrow we'll meet. Tomorrow I'll complete this SDT. And tomorrow I'll start the new topic. Okay? Only one session tomorrow. Tomorrow only one session.